Hey YouTubers, you've reached the Magnified channel. I know I haven't made videos for a while. I've been out of commission for a while. I was sick. I had some kind of stomach flu or like food poisoning, I think. And so, my gosh, that can really wreak havoc on one's life for a couple of days. But you know, this physical reality is just such a drag sometimes. But anyways, and plus this stuff right here is like really hard work. So in this video, we're going to be demonstrating the magnification of a magnetic field. And I don't think there's a real major difference between amplification and magnification. There's probably a difference, I'm sure, but to me it's all the same thing. It's basically magnification and amplification is if you have more of something. So the free energy in this system, or the over unity, is contained in the magnetic field, and I'm going to prove that once again in this video. So right now we have a 19 volt power supply. There's the 19 volts, and there's the 19 volt power supply right here. It's connected into the wall back there. This over here is set up for the second half of this demonstration, feeding power into this box. It's not connected to anything right now, as you can see. It's not part of what's being shown right now. Only the 19 volt power supply is what we're looking at right now, and you can see it's not doing anything. And that's the 19 volt power supply. Next we're going to compare that to the 12 volt power supply right here going into the box. And so right now we're going to look at the current and the voltage needed, which is actually about 1.92 watts. Let's calculate that real fast, just so we know what we're comparing to. We got 0.102 times 19.10. Okay, is about 1.95 watts. Okay, our target is 1.90 watts. Okay, so this 1.95 watts is producing a magnetic field of this strength right here, and you can see I got a certain distance between the edge of this base holding the coil here and this little tiny magnet and a piece of tape right here. And if you look at the distance, actually hold on a second. Maybe we can actually measure this with a ruler right about here. Now you can see, let's move that over just a little. Now we can see the distance, and if you look real carefully, you can see the magnet is being held up and balanced by the magnetic field coming off this coil. Let's see if we can get a better look at that. It's hard to see, but let's see here. But it is, there we go. So it is being balanced a little bit here. Let's see if we can get an even better look. There we go. That's the best I can get for a shot. But it is being balanced up. And so we're going to compare that to this 1.95 watts. we're going to put 1.90 watts right here into off the 12 volts over here. We're going to put 1.90 watts into the box and get about 2.76 watts coming out to show that the 2.76 watts that's coming out of the box and forming the magnetic field over here can push this much further. So let's play around a little bit with this 1.95 watts right here, and I'll just connect and disconnect and connect right here, and you can see I'm going to disconnect it right now, and then I'm going to connect it, and you can see that right there, right? See how it's being affected at that distance. Okay, so, and if I push it back further like this, then that's too far away for anything to happen here. See? Of course, that's not doing anything at all. So now I wanted to get this all in one shot, but I'm not going to be able to do that because I have to reconnect. Well, yeah, I got to disconnect all this and put it over here. So let's go do that right now, and then let's compare that to 1.90 watts going in. And then, so the 1.90 watts is going to be actually less than the 1.95 watts that's making this happen right now at this distance over here. So let's do that right now. Okay, now we got our 12 volt power supply connected right here. All right. And we've gotten rid of our 19 volt. What's over there now? Now we're just running it off the 12 volt power supply. And here's our input. And let's calculate that real fast. Our input is 0.154 times 12.31 is about 1.90 watts. Okay, that's going into the box now. But take a look at this. See, now our magnet is being held up at a much further distance. And to show that a little bit more clearer, let's disconnect that right here. And you see, I'm going to connect and reconnect. And you can see now it's being affected at a much further distance. Move it back. In fact, it might even be able to go further. Yes, it's going further. And we're doing that with the same, actually less than when we first showed the 1.95 watts, it could only do it about right here. Now we're doing it much further with the same, actually less than 1.95 watts. We're doing it with 1.90 watts, which I just showed right here, I think. 0.154 times 12.31. Yes, we're doing it with actually less wattage, about 1.90 watts. So here on our output of our box, right here is 19.57 times 1.41 is 2.76 watts. So we do indeed have a magnetic field that is comparable to the 2.76 watts. Okay, so we got a much bigger magnetic field. Let's just leave it on. We got a much bigger magnetic field than before. With the same or less than our original 1.95 watts. Actually 1.90 watts. So with the same 1.90 watts, we're getting a bigger magnetic field. We're getting a magnetic field that's worth about 2.76 watts. So here's another way of showing over unity contained in the magnetic field. All right, that's it for now. If you're new to the channel, please subscribe, and please like the video and share. And thanks for watching. I'll see you on the next video.